Hey guys, today we're going to do 8.4 on trigonometry, and I'm just going to do day 1 notes in this video. I'll make a separate video for day 2 notes, but our objectives are going to be the same for both days. So we're going to find trigonometric ratios using right triangles. Remember, chapter 8 is all about right triangles. And then we're going to use those trigonometric ratios to find angle measures in a right triangle. So that's probably going to be more towards what we're going to do with day 2 video. So, background. The word trigonometry comes from two Greek terms, trigon and metron. Trigon means triangle and metron means measure. So we're going to be looking at measures of triangles. A trigonometric ratio is a ratio of the lengths of two sides of a right triangle. Any triangles that have two angles that are congruent, those two triangles are going to be similar. So keep that in mind. And therefore, there's going to be some certain ratios that can be used for all right triangles. So we're going to get into those ratios here with our big table. So let's just jump right in. We're going to be looking at our three trigonometric ratios in relationship to angle A, and then we're going to look at them in relationship to angle B. So our first one is sine. That's how we pronounce that, is sine. On your calculator, we'll get to using this button, S-I-N button for sine. All right, so we're going to be working with some sides, and we're going to call them our hypotenuse, our adjacent side, and our opposite side. Hypotenuse is going to always be the one across from that 90-degree angle, no matter what angle we are referencing. But our adjacent and our opposite are going to be ones that are going to change based on what angle we're referencing. We're never going to do our trig ratios in reference to our 90-degree angle, though. Okay, so it's always going to be those other two. So let's go ahead and start with, we're going to look at it in relationship to angle A. So we have opposite, so the opposite is straight across. So that's our A. And then our hypotenuse, which we've already determined is always going to be C in this triangle. So sine, opposite over hypotenuse. Then we have our cosine, and you'll see that as the COS button on your calculator. And that one is going to be adjacent over hypotenuse. We are still referring to angle A, and this time adjacent is the one right next to it. So we are going to have our adjacent is B over our hypotenuse. Hypotenuse is still C. Then last one is going to be tangent, and that's our TAN button on our calculator. And this one is going to reference our adjacent and our opposite sides. So in tangent, it's opposite. So in relationship to A, we know our opposite is A, side A, and our adjacent, which is side B. Those ratios can be represented as fractions or as decimals. So depending on what's being asked for, make sure you're giving the correct answer for that. Then lastly, you'll see we have had up in the corner of each of these, we have so, ka, and toa. So represents sine of opposite over hypotenuse. So this is a little mnemonic device to help us remember. Ka, C-A-H. Cosine, adjacent, hypotenuse. So cosine is adjacent over hypotenuse. And our last one, toa. Tangent is opposite over adjacent. All right, so next I'm going to have you guys do the other column for tomorrow. It's going to be referencing angle B. So let's just decide together. One across from it is going to be our opposite, and the one next to it is going to be our adjacent. So go ahead and try those trig ratios out for yourself. Let's go ahead and try this one. It says express each trig ratio as a fraction and a decimal. So we're going to be having two answers here to the nearest hundredth. So A, B, and C are all referencing to angle J, and K is going to be referenced in D, E, and F. So here's angle J, and let's just label the sides together for angle J. We know that we are going to have our hypotenuse here. So that's our one across from our 90-degree angle. We have our opposite straight across and our adjacent right next to it. All right, sine. Remember, SOHCAHTOA, SOHCAHTOA. Opposite over hypotenuse. So our opposite is 5 and our hypotenuse is 13. If we go ahead and we round that or make that a decimal, so 5 divided by 13, round to the nearest hundredth, we get 0.38. Cosine. Cosine, remember, is our adjacent over hypotenuse. Adjacent this time is 12. Our hypotenuse is still 13. We're going to make that into our decimal. So divide 12 by 13, and we get 0.92. Then lastly, we have our tangent, which is our opposite over our adjacent. So 5 over 12. Again, take that 5, divide by 12, and we get 0.42 when we round it to the nearest decimal place. Go ahead, pause the video now, and I want you guys to try out D, E, and F. All right, there I have the answers for you. I hope you pause the videos. Check your answers with my answers that are given here for you. Remember though, when we are switching, and we're going to talk about it in relationship to angle K, that this has now become the opposite and our adjacent. So our side switched there. All right, onto the back side. It says find sine of L, cosine of L, and tangent of L. This one, if you guys can see, has some square roots in it. Nothing to be afraid of. Remember, we're all okay with square roots. So I'm just going to jot up here our SOHCAHTOA. I write this on the top of every page. On every page when I'm doing trig functions. All right, our sine of L. So we are going to be looking at angle L. And we are going to be wanting our opposite over our hypotenuse. So our opposite is 2 square root of 3 over 2 square root of 15. Normally we don't want to leave those square roots in there, so let's switch it over to a decimal. If we do that, we get 447. All right, let's see what cosine brings about for us. Cosine of L, so we're still talking about L. Remember, we made this our opposite. So this one's going to be our adjacent. So cosine now is adjacent over hypotenuse. So we have 4 square root of 3 over 2 square root of 15. And I want you guys to put that into a decimal again. If we go ahead and divide those two, try it, pause the video, try it out. I got 894. I want you guys to try the tangent by itself and see what you can come up with there. All right, so let's actually put this into a real world problem here. A fitness trainer sets the incline on a treadmill to 7 degrees. So that means that from the ground to the treadmill, it's going to have this 7 degrees right here. The walking surface is 5 feet long. Approximately how many inches did the trainer raise the end of the treadmill from the floor? Excuse me. So if we look here, here's our angle. What do we have in reference to our angle? Well, we have the one that's straight across. So this one's our opposite. We have the one that's across from the 90-degree angle, so hypotenuse. So think about SOHCAHTOA. Which one uses our opposite and our hypotenuse? Yeah, that one's going to be our sine. So now we have sine, and we actually have our angle measure here. Sine of 7 degrees equals our opposite, y, over our hypotenuse. Now we want to solve for y, so we want that y by itself. So we need to get rid of that divide by 5. Well, think about what's the opposite of dividing by 5? Timesing by 5. So y is going to be 5 times the sine of 7 degrees. I want you guys to go ahead and look at your calculator. I'm going to bring mine up here, so just give me a moment. All right, so there's my calculator. Let's go ahead and make sure that it is in degrees, because remember our angles are talking about degrees. So if I go to my settings, and I want to go into my settings too, and I want to be looking at my general settings. If I look at my second one, it says angle. Let's go down. There we go. Angle. See how it says radian? I want that to say degrees. So if I switch that over, go down, I want degrees. Now it says degree. So in this Inspire calculator, you want to change that so it's make default. That is going to make it become degrees every time you do the problem. If you are getting a negative answer when we get into here, some really funky weird decimal, bring your calculator to class. We'll figure out switching it from radians to degrees. All right, so we're going to put in 5 parentheses. If I find my trig functions, most calculators have a button right at the top. I want sine of 7, and I see that it doesn't have my 5 in there, so let's go back to the beginning. 5 times the sine of 7, and I see that I get a decimal here, and that's not what I want. Just a moment. Let me pause the video and get this figured. All right, well, that was my mistake on my answer key. So this is what we want. So this is great. So we get y equals, and it's a 0.6. And we got to think about a label for this one. This one's going to be feet. So that means our treadmill's been raised just a little more than half a foot to get that 7 degrees. All right, so here, find the value of x. So we have an angle here, and we are given the opposite, and this time we are given our adjacent. So ka, toa. We have opposite and adjacent. This time, it's going to give us tangent. So we set up tangent of our 25, our angle, equals our opposite over our adjacent. Again, that x is in the top, so we are going to times by 18 to get rid of that divide by 18. So 18 times the tangent of 25 is going to be our x. So let me grab my calculator here. I'll move it over so we can look at what we're doing. All right, we're going to take 18 times the tangent, so make sure you're pulling tangent this time. All right, of 25. If we hit enter, we get 8.39. Let's round that to 8.4. 8.4. If we look here, there was no label, so our answer is just that 8.4. All right. Take a look here. The bottom of a handicap ramp is 15 feet from the entrance of a building. If the angle of the ramp is 4.8 degrees, about how high does the ramp rise off the ground? Okay, so we only are given one side here, and in relationship to our angle, that side is going to be our adjacent. And we need to figure out, it asks us, how high does the ramp rise off the ground? So that's going to be this value right here, which is our opposite from our angle. So katoa tells us that we have opposite and adjacent. So again, we're going to use that tangent. So let's just get it written out together. Tangent of the angle equals opposite over adjacent. All right, I set it up for you. So this time I want you to finish it out and come with that answer for tomorrow. Here's our last one. I'm not going to help you at all about this one. This one's all your own, and I'm excited to see what you guys have to say with it for me tomorrow. Thanks, guys.